So we're going to start off with, actually, let's do this first because I'll forget to do this. Let's go over the roll real quick. Just let's see, I got 4, 2, 3, 4, 16. Wait, and then over here 16, 17, 18, 19, 20. So we got 26. We should have 2 missing, I guess. So instead of me calling off names, if should we start in the front or the back? Front. Okay, so I go by with whatever here first. So we'll start in the front. Should we start at the left or the right? Left. Your left or my left? No, let's start over here then. Noah, wonderful. Noah Clark. Okay. Actually, how about a name? And what else do we want to know about people? How about your major? Because then maybe we got some similar majors. So you're.
I'm going for business management.
Business. All right. Business management.
Sarah in health
Sarah in health sciences.
sciences.
Sarah Tundas?
Yes.
Okay. Because I might have more. Awesome. Nice to meet you, Sarah.
Spencer.
Spencer. Do I know you?
I don't
Have I?
think so.
Okay. You were looking familiar, but maybe.
Psychology and teaching.
Awesome. 2 great majors.
Elena.
Elena.
Business.
Helena. Oh, there you are. Yeah. There we go. Maria.
Architecture.
You're in architecture. I like doing this so that I have to look over the whole list. Moldano?
Yeah.
Okay.
Anne.
Anne.
And I'm doing forensics. I'm almost done actually. It's my last semester.
Excellent. Ann Turner?
Mhm.
Awesome.
Madeline, but you call me Maddie.
Maddie.
Okay.
McKay, awesome.
And psychology.
Another psychology. So that's the other reason why I have that, and maybe study with others.
Capri.
Capri.
I'm studying business and agriculture.
Capri. There you are. Okay. Business and okay. I used to teach at Oregon State. We had a lot of that.
Yeah.
So awesome. Pain. And what are you studying? Pain. Chemistry. Awesome. There we are. Chemistry.
I'm Ryan.
Ryan.
I'm a finance major.
Excellent. I spent 13 years in what was it? Financial planning. A lot of stress, but it's fun. It can be fun.
I might switch.
You might. Well, that's all. This is a great field if you can. My boss was great at it, and actually, he's like, I'm still doing some business with him. He's like 75 now. He's retired, but he still loves what he does. For me, it wasn't my cup of tea, but he loves it. So, yeah.
I'm Layla.
Layla
Biology.
in biology, awesome.
Diesel. Not decided on a major.
Okay, still looking. That's good. Those of you that are looking, I'm going to try to steer you over into education because we need good teachers. And the great thing about teaching is you can do it with anything. You find what you love to do, you can teach, and you can teach part-time and have a full career too. So that's the other things. You can do your finance stuff and then evening come teach a few community college classes. That's what's great about the community college. All you need is a master's degree in any field. You can teach some. You can become an adjunct. It pays pretty well. So. Angelina, civil engineering. Angelina, you got to be here. Angie? No, Angie Ray? Okay. Angelina, there we go.
Josiah and business management.
Josiah. Where are we? What's the last name? Oh, there you are. You were hiding between my sloppy checks. There we go. That's why I missed you.
James in business law.
James. Help me out here with the last name.
Dalzell.
Oh, there we go. Yeah. Made my checks too big.
Ella, and I'm studying psychology.
Ella in psychology. It should be getting easier to find people. Oh, there you are. All right.
My name's Dalton, and I'm studying business.
Dalton in business. I saw you here. There we go.
Mason.
Mason.
Business.
There we are.
Sophia and interior design.
Interior design. We've got a great program here. And Sophia. Okay. Good.
Ethan and physical therapy.
Ethan in physical therapy. Nice. Oh, that's why you're right at the end. Okay, thanks.
Isabel in health science.
I saw you here somewhere. Isabel. So how many have we had so far in either nursing or health? I think we've got 3, maybe 4.
Shayla.
Shayla.
And I'm studying dental hygiene.
Dental hygiene, so same. Okay, good.
Cora, I'm also doing dental hygiene.
Wonderful. And you knew who to hook up with here, huh? Good. Awesome. Cora, where are you? There we are.
Ryder in business.
Business, awesome.
Luke in business.
Luke. There you are. Yeah. Thank you. And last. Tyler. Aviation. Oh, that's nice. Are you looking to fly or to design? Okay. So let me just try. Marco is not here, and Anthony. Okay, so that's the 2 that I got missing. Good. Got everybody else here. I'm tired. Let's just call it a day. We should probably move on. Okay, so we'll go about, I think in a half hour we'll get through most of this. So we're going to look at functions. We're going to talk a little bit about what makes a function, what's not a function. And in this first set, how many of you have done things with functions before? Quite a few. Again, maybe you haven't. So we'll go through, but we'll try not to be too painfully methodic. So we start by talking about a relation. That's a set of ordered pairs. So an x and a y. Yes, sir.
You said this will be online?
Yeah. So I'm going to record. Yeah, it's still recording. Yeah, 58 minutes in, so it's recording, and then I'll post it. Probably jump it to this section. So there's an ordered pair. Now relation, there's no any two, x and y. They can be paired up any way we want them. We call the first part the domain. This is our input. And the second part is called the range, which is our output. And if it's just a relation, this won't. I got too tricky. Let's keep these. Oops. Won't let me edit. So I wanted to take these off one at a time, but we'll just go this route. So all of these are relations, but to be a function, there's a special rule that they didn't put in here, but a function is that each input has only one output. So on this first one, each of the inputs is paired up with an output, so that's a function. It's a relation that's a function. The second one, each input is paired up with a different output, or with one output, so that's a function. Now, this first one, even though Q and R go to the same output, that's okay. It's just that going from the input, they each have only one output. Okay, so a function has that special rule, but it's sort of like a double standard. While each input could share an output cannot share the same input. So if I have an input, such as Q, that's getting matched up with two outputs, that is not a function. Okay, and we're going to see the reason this is that because when we graph it, it creates things like circles, and it's a little ambiguous to work with this world. When I was studying, we didn't have this concept of function. This came along in the late 80s. And so when I was studying college algebra, we started with the algebra of circles. We don't do that. We wait till we move circles off to trigonometry, and we do it in a way that it fits this whole definition of function. So a function is, at least for mathematically speaking, it's relatively a new concept as far as the strict concept of the way we use it. So in this class, it's going to be the way we're teaching math now. It's all about functions. So we won't deal with circles. We won't deal with things that are not functions. We put them off till later. Okay. So here's our formal definition. A function is a relation in which each possible input value leads to exactly one output value. Notice there is no restriction on the output value. That's usually the mistake people will make, is, oh, this output had, going back, it has two inputs. It's okay. So each input makes up the domain. So, and again, at least when we talk about our graphing calculators that we'll probably be using, the input will be the X, the output will be the Y. We'll see that in this textbook they mix things up. They use different letters as well. So you want to, it could be switched, but whatever is the input, that's going to be what we also refer to as the domain. So that's all the possible inputs. And then we also talk about the range, which is all the possible outputs. Okay, so we'll... And again, this is an area that I sort of struggle with because it's an ordered pair. The order is important. From left to right, input comes first and then output. The problem is we're going to see very quickly when we use English to describe mathematics, sometimes the language itself doesn't follow the same pattern. Okay. So again, in part I'm using somebody else's PowerPoint, so it's a little more detailed than I would necessarily be, but this is basically what we're going to be dealing with is somehow an input. So the process is we have an input, we have a function. This is where the math happens. Maybe something's being multiplied, added, or something's happening inside here, or plus or minus. The input comes in, we add, subtract, multiply, do something to it, and out comes the output. So whatever's happening in here is what we call the function. It's a process. Sometimes it could just be a random thing. Give me a number and I'll put it over here, So it could be random, it could be, but there is some sort of process for assigning this input gets matched up with that output. Okay, and mostly what we'll be looking at is the math portion of that. So this is where it gets confusing, at least to me. is this statement: is price a function of the item? So we've got an item and we've got a price. So one of them's the input, one of them's the output. And this sentence is supposed to tell us which one. And now if you're thinking like me, well, input came first on the ordered pair and output came second. So when you're reading this, you're maybe starting to think that way. But when they use this a function of, this second part over here is actually the input. Input is second. The output came first. So when they use this sentence construction, the first thing they're going to talk about is the output, a function of the input. And I guess it makes sense because the input is going through the function, but notice how the order has changed, reading from left to right. And if I do it as an ordered pair, it's the other way around. Maybe that's one of the outcomes of the way it was translated in Arabic. In Arabic, it was reading output and then input. And now when we put it into English sentence, it reads the other way. So the thing is we kind of always have to focus on this function of. So the second thing is the input. The first thing is the output. So let's just think for A, if price is the output and item is the input, is this a function? Does each one of these input items have only one output? They do. There's only one price. If you get the plain donut, you have one price. Jelly donut, you got one price. Chocolate donut, you got one price. So that's a function. How about if we switch it, is the item as the output and price is our input? Is that a function? No. Why not? If you give me the input of 199, which one is it? It could be jelly donut or chocolate, right? It's going to two places. That's not a function. Okay, so we deal with things. Sometimes we've got a function that works one way, but it doesn't work backwards. We're going to see, and you may have seen some of these, it's called a one-to-one function, a function that works both ways. It's a function if this is the input and that's the output, and if you switch it, it's still a function. That's called a one-to-one function. Okay. Let's go through a little bit quicker. So a function of, remember this is, which one is this? The second is the input. It's backwards. That's all I can remember. This is our output. So is grade point average a function of the percent grade? Percent grade. Yes, no matter what your percent grade is, 78, 79, 80, you're going to get a 3 point. So whatever it is there, it's going to get 1. However, if we switch, so yes. If we switch it, is the percent grade a function of the grade point average? So if you know that you had a grade point average, are you able to pinpoint what the percentage was? No, because if you have a 2.0, you could have had a 67, you could have had a 68, you could have had a 69.4. So there's a lot of, so it's got many. Okay, so this is not a function. Okay, so just kind of, so part of what we're doing is we're just identifying what's a function, what's not a function. Let's see. Is the rank a function of the player name? So rank is the output. Here's the player name. We know the player name. How many ranks do they have? 1. So that's a function. If you know, is the player name a function of the rank? So if the rank is the input, will that get you to only one player name?
Yeah.
Yeah, so this is a one-to-one function. So it's a function in both directions. See how that works? But also see how it, again, this is one area that I struggle because I read it in the wrong way. A function of inputs over here, outputs first. So it's switching the order on us. We'll use function notation. So one of the things, we've got an example we'll work on. function notation is just, like in algebra, we talk about the linear equation, y equals mx plus b, right? With function notation, we just change that to f of x equals mx plus b. What this is it's really just it's a replacement symbol for y. F is the name of the function, so we could use different letters for that. And that parentheses x is so that we can also carry the input with it. Okay, so it allows us, when doing this function notation, I could say that f of 5 equals, say, 7. And when I do this, I know the input is 5. And I know the output at the same time here, too. In the old days, you would maybe plug in, you would be given that x equals 5, you plug in, you do a bunch of calculations, you get y equals 7. So that would be the same thing here, but now with using function notation, we're actually carrying that input along so that on the last line, we don't just have y equals 7, we have f of 5 equals 7. So we have both the input and the output side by side. And we'd also write it as an ordered pair. This time, if we write it in this order, it matches up with the ordered pair. Okay. So if we give this function f of 2,500 equals 300, what does that represent? Could someone turn that into a sentence for us? What does the 300 represent? What's the 2005 represent? Yes, sir.
The 2005 is the input to become second?
Yes.
Okay. And the 300 is the output.
Very good.
So it would be that there are 300 police officers in whatever town in 2005.
Very good. And before we go too much further, I don't know why it seems to be with math people, but they always do this thing. I did this one at Oregon State. They had this activity on exponential growth. It was exponential growth of prisons. I said, well, what is this hang up with math people and prisons and criminal justice system? I don't know. So I tried to change them all, but I don't always catch them.
I like it. I'm a criminal justice.
Yeah, and if you're a
Forensics.
it's all okay. But I said, can't we have? In fact, I may show you. I've got this anyway. Can we have things that are growing that are positive? Okay. So using function notations for days and months. Again, this is a little deeper than I need, so I'm going to skip over some of this. So I want to get here. So then what we're going to do is, so we know there's going to be an input, there's an output. Input, we do some math to it, we get an output. So there are two processes using functions that we use. One is called evaluating, and we do that whenever we know the input value. So this is, we know the input. We will do what's called evaluating. Now sometimes just with our, we get a little sloppy with our English. We call this solving. We kind of know what we're doing, but there's a difference between solve and evaluate. We'll see that solve is when we have the output value, then we solve for the input. When we have the input value, we evaluate to get the output value. And you kind of see, we'll do a few of these processes. So the way this works is -4 is an input. So we can write that as h of -4. What do we do with that -4? We're going to put it in for each of these p's. And p is just a variable. It's marking a spot. And what I like to do first is I rewrite p as a set of open parentheses plus 2 times p. Because when you have parentheses, it's a lot easier to plug things in. If you have a p, you can't put something on top of it, right? So do this first, and it kind of shows you what do we put in these parentheses. We put the -4, and I'll even change colors here. And again, the idea of the function, this is where the math happens, the arithmetic at least. So -4 squared gives us 16, positive 16. 2 times -4 gives us -8. And again, we can carry this down. And as we do that, 16 minus 8 is 8, so we have our input is -4, our output is 8. Okay, so that's evaluating. And again, you're going to get some practice with this. They'll get given some functions. If we have a letter, let me do this one, h of -a. Sometimes that throws people, what am I supposed to do with this? Well, again, rewrite the function as parentheses squared plus 2 parentheses. And whatever's in the parentheses on the left side goes into the parentheses on the right side. And now a letter is just a variable or an unknown. There's two types. So there's a variable which is it's something that could change. Sometimes though we use these letters as unknowns, so they're a number but we don't know what it is. Those are kind of different, because an unknown is, once we do know it, it's fixed. A variable is something that will vary, that we can change. So we've got those two types of letters that we use. So when we go through with this, we'd have -a. So if you take -a and square it, -a times -a, you get a positive a squared. So in some sense, when we got letters, it's actually a little bit easier. We didn't have to know that 4 times 4 is 16. We don't have to know what a times a is. We just know it's a squared. So we leave it at that. And then 2 times -a, we're going to have -2a. And I say, where's our answer? It's right here. It's still sort of like a formula. But since we don't know what a is, we can't carry this calculation any further. We have evaluated as far as we can. So when you're asked to evaluate with letters, put them in and just treat those letters as sort of new variables, and we'll go from there. Okay. And again, we got more things we can try. Maybe we'll do this last one. So g of 5, again, square root m minus 4, and what goes in that parentheses, 5. And then we do the math. 5 minus 4 is 1, so we have the square root of 1, which is 1. Okay, so again, that's evaluated. This is where we get to solve, and this is because of the notation and what we've been doing. A lot of folks, what they do is when they see this, they'll plug in 4 for x. But is that what this is saying to do? No, it's saying 4 is what? It is the output. It's the y. It's the function value. So it's an output. And so if we see it, it goes right here. It doesn't get plugged in for x. That's what we're trying to figure out. What do we need to plug in to get 4? And so this is where we actually call solving. It's not evaluating now. So we put the 4 over here. And then we would solve for x. And that's quadratics. That's like a couple lessons down. I don't know why they gave us one of these where we could spend probably a day learning how to solve this. So we'll do that later. But this is, we could solve this for x, but we need some more techniques. And the same thing with this one, right? This is saying the output is 2. So we put 2 equals the square root of m minus 4. Now I think we might have some of these in the homework, so I'll just, and this one won't be too hard to solve. If we have a square root, what undoes a square root? A square. So if we square both sides, and again with equations, as long as we do the same thing to both sides, we're okay. So the square will undo a square root, which means that's what's left is m minus 4. 2 squared is 4. And then now we've got a linear equation, and we can solve this, adding 4 to both sides. and we get that m equals 8. Okay, so there's us to solve and evaluate. So this is basically what we just did. So we can use all the algebraic methods. When we go to solve, we isolate the output. So that's what we were doing on one side, and then get everything else over to solve for the input variable. That's what I mean. Usually I like to look at these things. So we're given this relationship, 3r plus 2t equals 18. Do we know which one's the input or the output? Not yet. They haven't told us. But they're starting to tell us here which one's the input and the output when they tell us what the function that they want, right? Because actually either one could be the input or the output at this point. Usually we know the input or the output is the variable that's by itself on one side, but we aren't there. So this is telling us which one is the output variable. It's outside of the parentheses, so that's our output. What's the input variable? The one that is in the parentheses. So this is one. Sometimes the language and everything matches up. So they're telling us is they want us to write this with the t being the input, r being the output. So what we need to do is we need to get r by itself. We're solving for the output variable, right? What would be the first thing? How can we get r by itself?
Divide it by itself.
I think subtract 2t.
Okay, good. Here's where both of those are okay to do. We could do it either way, but so usually we do PEMDAS, right? Parentheses, exponents, multiplication, division, addition, subtraction, PEMDAS. When we're evaluating. When we solve, we do everything backwards. So we do SADMEP. We do the subtraction addition first, then the multiplication division, then the parentheses and our exponents in parentheses. So we want to kind of do things backwards. So yeah, we'll take care of the addition actually first. So we'll subtract 2t from both sides. So then we get 3r equals 18 minus 2t. But r is not by itself yet. What do we need to do to get r by itself? Now's the time to divide. It's a little cleaner. We just divide this whole thing by 3. So these guys cancel, and we get that r is now equal to 18 minus 2t over 3. And we could leave it that way. You could also divide the 3 into both of those. So if you wanted, you could also write 18 divided by 3 is 6. And then 2 divided by 3 is just 2/3. We'll leave it that way. So another way to write it, both are correct, but now we've got it in function format. And if we wanted to, we could rewrite this. Instead of having r here, we could say that this is f of t. And again, you could use either form. And then now you could evaluate. You could also solve just like we did earlier on. Okay, let's try this one. Getting a little more complicated. So we want y as a function of x. Again, which one's the input? X. So the one that came second. This is the output. So remember, we want to solve for the output. We want to get the output by itself. Which should we do first?
Get y on the other side.
Good. So some might want to subtract x from both sides. I see a negative y. I don't like negatives because they cause me a lot of headache and a lot of problems. So yeah, get y to the other side. And since there's a 0 here, it's going to be alone, right? Because you add, so that's a perfectly good way to do it. So then we get x equals 8 y to the third. Good. Again, goal is to get y by itself.
We divided 8.
We divide by the 8. Good. So now we have y to the third is x over 8. This might be a stretch. How do we get rid of a cube if we have something that's cubed?
Cube root.
We can use a cube root. So that's one of these things, because if you have if you take the cube root of y cubed, you get y. It's the same thing. A cube root is the same thing as going to the 1/3 power. And if you take 1/3 times 3, what do you get? Y to the first power. Okay, so that's cube root is just a 1/3 power. So either way you want to look at it. But we use this cube root probably because of the printing presses. It was easier than a fractional exponent. So cube root of y to the third is y. And our function now is the cube root of x over the cube root of 8. But what's the cube root of 8? Because 2 times 2 times 2 is 8. So it's again, some simplifying that goes on. It's kind of like we dived into the deep end on some of these things, or then also the next section we're going to look at the different graphs and such, and then later on we come back and we deal with these more specifically. So that's our function, and again, we could just leave it like this. You could, when you have an equal sign, you can always flip it over. If it's easier to read, you could go that route. And again, you could also use function notation, so you could replace y with f of x. Cube root of, no. Cube root of x over 2. Okay, so either would be fine. I think we're almost here. Yeah, so we're going to talk a little bit about, so we talked about evaluating and solving when we have a function, when we have an equation. We have symbolic, we have x and y's and variables. Another way to look at a function, though, is if we just have it in the tabular form. It's a table. We have the inputs, we have the outputs. There is no equation here. There's no. So the only way I know, I don't know what 1.5 would be as an input. Maybe it's not even possible. All I know is I can know if you give me an input of 1, 2, 3, 4, or 5, I can get you the output. So to find g of 2, that means that 2 is the input. I go to the input and I look up the output. And it's as simple as that, but sometimes you get so used to plugging into an equation or something, it seems like almost too simple to be true, but that's all we do. And these are the ones that people will, later on, that they actually miss them because they get so involved in all these different techniques. And this one is just, it's a look it up, right? If they give us an output, what do? We find the output and look for the input. So it's just a reverse lookup. So when we have a table, that's all we can do is we go to the table and we look up whichever they give us. So they gave us the output of 7. Is it possible if they gave us an output of 7 that we could have 2 input values and still be a function? It is. But if they give us an input value, there's always only going to be one output value because we're dealing with functions. But it is possible to have that we could have had 2 answers. But in this, like 8, if they gave us 8, 8 has 2 answers. 6 has 2 answers, 2 different inputs, right? But 7, in this case, then we would say n equals 3. So it's just look it up. We go to the table, look it up. If we're given a graph, it's kind of similar to looking on a table, except if we're given the input, we look along the x-axis for that value. So we look for -1, and then we go either up or down until we hit the graph. In this case, we go up until we hit the graph, and we find the output value, the y. So that's going to give us 4. So again, graphs, sometimes it's just we're blocked because we get so much into using the equations and all these different techniques for solving equations and evaluating equations. We get to something like this, which is just look it up on the graph, and it seems like we forget. But and then if they give us the output, what do? Look for the input. So we're actually on the y-axis, is 0 is here, and then we go either left or right till we hit the graph, and in this case we hit the graph here, so the input is 1. Okay, so so it's a directional thing again. And again, it's something that I actually struggled a lot with because I'm coming from the wrong side. You mix up your orders and everything is messed up. You just get your ordered pair backwards and everything is wrong. But sometimes that's the good thing, is the good news is if you're missing every single problem, that's actually easier to solve, easier to fix than if you're just randomly getting some. Because if it's random, you're not doing something consistently. But if you're doing something consistently wrong, we can figure out what that is, and then you go from being consistently wrong to being consistently right. And this is the one we talked about, one-to-one functions. I think most of this we're going to pick up on Monday. We talked about each input having only one output. So graphically, that boils down to something called the vertical line test. If we do a vertical line and it touches the graph in only one place, then that is a function. If it touches it in more than one places, anywhere, it doesn't have to be in multiple places, but then it's not a function. So we see things like this middle one is not a function. Certainly ellipses, this is ellipses, circles, they're not function because a vertical line would hit it in 2 places. There's some in the homework that are like that. And again, we can just use the vertical line. We draw as many vertical lines as we need, and we see it hits it each time only one place. This is a function. This one, there's a vertical line, it worked, but we have to draw every single one. This one didn't work, it touched it in 2 places, not a function. And then this one, there's this red line here that's actually an asymptote, so if you go through here, it doesn't touch either of those. This actually is a function. Okay, because it would pass the vertical line test. Let's see, we're almost there. How about this one? Does that represent a function? Passes the vertical line test. Good. Horizontal line test tests to see if we have a one-to-one function. So both of these are functions, but will this pass the horizontal line test? Let's pretend that was a horizontal line. How many places that touches it in 3 places, so that it's not one-to-one. And that means that if you give me the outputs, I'm going to get multiple inputs. So it's not that we won't deal with it, but it's a function that doesn't have an inverse. How about this function down here? Is this a one-to-one? Drawing horizontal lines, it's all just going to touch there once, right? So this one is a one-to-one. This one is, this one not. Okay, and you'll see it becomes more important when we start talking about inverse functions. Inverses, so that we can go backwards and find the answer. You need one-to-one on inverse. Horizontal line test, that's already there. And then we're going to get into these basic functions actually into the next section. I think we're almost there. Yeah. So what we'll do is on Monday we'll pick up here. What we're going to do is then we're going to take a view of several different functions, we'll go in and we'll take a look at we'll be ready to take a look at the test, the online test, the practice test. So Monday we'll have about probably 30 minutes of instruction and the rest of the time to start working on the homework. Thank you all. Thank you. If you've got questions, feel free to come up.